Hello and welcome to Research Bunny. We're thrilled to have you with us today as we delve into a fascinating frontier of study that intertwines the marvels of artificial intelligence with the enigma of human language origins. Today, we're uncovering insights presented in an intriguing academic paper titled, "What Artificial Intelligence Might Teach Us About the Origin of Human Language." This thought-provoking work is spearheaded by Alexander Kilpatrick from Nagoya University of Business and Commerce. At the core of human civilization is our ability to communicate through language, yet its origins remain one of the most compelling mysteries we face. Have you ever wondered how our ancestors transitioned from expressive gestures to spoken words, or how certain sounds might inherently convey specific meanings to us? This paper challenges some conventional thoughts in these realms, questioning the long-standing gesture-first hypothesis and examining the curious phenomenon of sound symbolism. Why does this matter, you ask? Well, understanding the origins of language isn't merely about uncovering the past, it's about gaining insights that could influence modern communication, artificial intelligence, and even our social interactions. Imagine if we could decode how sound symbolic patterns work and harness it to improve eyes' interaction with humans or to enhance language learning technologies. Join us as we navigate this academic landscape, examining the compelling evidence suggesting non-arbitrary sound-meaning relationships that transcend languages and cultures. We'll also explore the methodical approach used in analyzing sound symbolism through Pokémon names. Of all things, a creative approach that promises to reveal new layers of understanding about how sounds associate with meanings related to survival and combat. So prepare yourself for a ride through the winding roads of linguistic history and AI innovation as we dissect how these mysterious sound patterns help decipher the world's oldest communication tool. Stay tuned as we break down the intricacies of this research right after a short break. Welcome back, everyone. Let's dive deep into the heart of today's discussion, a fascinating exploration of how artificial intelligence can illuminate our understanding of language, particularly within the delightful realm of Pokémon names. The literature behind this study sets a strong foundation by addressing a long-standing debate, the balance between arbitrary and non-arbitrary sound-meaning relationships in language, a question that traces its roots back to Plato's time. Historically, this debate has puzzled scholars and linguists alike. Imagine taking two seemingly unrelated elements, sounds and meanings, and exploring if they are indeed arbitrary or if patterns emerge when we look across different languages. The mystery deepens with sound symbolism, where certain sounds predict specific meanings. A prime example is the kiki-booba effect here. Kiki is often associated with spiky shapes, while booba sounds round and soft. It's as if the very phonetics of these names carry a visual depiction within them. In the realm of studies focusing on nonce words, those invented purely for research, there's consistent evidence showing that sounds consistently map to sizes, often described by the frequency code hypothesis. But how do all these come together in the world of Pokémon names? This is where things get interesting. Pokémonastics takes these elements of sound symbolism and throws them into the wild environment of Pokémon attributes, where survival and game strategy matter. Earlier studies introduced us to the power of machine learning models, specifically random forest algorithms. When tasked with classifying Pokémon names based on their sounds, these algorithms exhibited a curious tendency. They overpredicted stronger Pokémon, those ready for post-evolution challenges, more often than not. It appeared as though algorithms had an inherent bias towards identifying threats. Parallel findings in human names demonstrate gender classifications exhibiting similar skewness, posing the thought-provoking question, is there a natural inclination programmed into the way these algorithms listen? So, why might this be the case? Here we dive into error management theory, EMT, which posits that it's evolutionarily advantageous to err on the side of caution to classify something as a threat when it's not, rather than the reverse. In nature, missing a threat could spell doom, but a false alarm is much less costly. This particular investigation shifts gears by using state-of-the-art XGBoost models instead of their random forest predecessors. The goal is to decipher if these error tendencies are algorithm-specific or a broader trait in machine learning when exposed to sound symbolism. The meticulous research employed datasets from Japanese, Korean, and Chinese Pokémon names. This meticulous choice of languages hopes to reflect a diverse yet focused exploration of sound symbolism. As we delve into the study's methodology, one must admire the attention to detail. Pokémon names were dissected to count speech features, translating these into an interpretable dataset for the algorithms. High null values, essentially the gaps in data, were addressed by implementing a robust technique known as threefold cross-validation, ensuring the models are not only accurate but resilient to overfitting. The focus was on 4 specific traits: attack, defend, height, and weight. Combat-related traits were the spotlight, with height and weight acting as control variables, since unlike attack and defend, they don't directly affect the in-game confrontations. Here, 2 intriguing hypotheses emerged. Will over 50 of the errors classify non-threatening sounds as threats? And will the combat-focused models exhibit more of these errors compared to size-specific ones? The machine doesn't disappoint. Accuracy soared above the halfway point of 50 in various tests. Yet, of particular note, it was the attack model and its fellow combat-focused counterpart that demonstrated higher false positive FP errors, the classic cautionary tale of classifying non-threats as threats. Another captivating aspect is the correlation between name length and perceived power. Hugely noticeable was the longer is stronger principle, where longer Pokémon names often correlated with higher attack and defend attributes. This wasn't as pronounced with height and weight, except in the Chinese dataset, which resisted this trend slightly. When the numbers were crunched and the data plotted in Table 4, the results pointed to an undeniable pattern. Combat-oriented models not only showed higher FP error rates compared to their size-focused peers, but did so with statistical significance, an insight that aligns so well with the theories of EMT. Throughout all of this, one cannot overlook the underlying suggestion there might just be an innate feature in how we process sound symbolic information that even sophisticated algorithms mirror. It's as though these digital entities, through analyzing Pokémon names, glance at a slice of our language's evolution and perhaps a bit of its soul. Stay tuned as we continue to explore fascinating insights from this intersection of traditional linguistic debates and cutting-edge technology. We'll be right back after a short break. As we draw this discussion to a close, let's recap the intriguing insights we've uncovered from this study. At its heart, this research examines the biases displayed by machine learning algorithms while classifying Pokémon names specifically, looking at how these biases align with evolutionary theories of error management. The study notably highlights a tendency for these algorithms to make more false positive errors, mistakenly identifying non-threats as threats when tasked with evaluating combat-related attributes like attack and defend. This suggests that, in an evolutionary context, such cautious behavior could have been advantageous, allowing early humans or even artificial agents reflecting this pattern to minimize the risk of overlooking potential threats. The significance of these findings cannot be underestimated. They challenge the traditional gesture-first hypothesis of language origin, pushing us to think beyond gestures and consider the profound impact of sound symbolism in the evolution of language. This, in turn, could reshape our understanding of how human languages might have developed, demanding further exploration into the systematic patterns we subconsciously associate with sound and meaning. Moreover, these findings might ripple beyond the academic world and into our everyday lives, particularly as AI continues to grow and integrate into various facets of society. Understanding these inherent biases in AI could inform better design practices, ensuring that algorithms employed in sensitive areas such as security or healthcare make judicious, well-informed decisions. Before we part, consider this: if our current tools reflect these foundational biases, what does this say about the future evolution of language in artificial intelligence systems? Could AI one day speak a language grounded in its unique logic and patterns? These are questions worth pondering as we continue to explore the intersections of technology and linguistics. For those among you keen to delve deeper into these discoveries, the full text of the academic paper is available on the Research Bunny app. I encourage you to explore it and share your thoughts with us. Thank you for joining us today. Remember, at Research Bunny, we're committed to making cutting-edge research accessible and engaging. Until next time, keep questioning, keep exploring, and let curiosity guide you to new horizons.